Hey everyone, my name's Sam. I help lead developer experience here at Superfluid, and today I'm really excited to be bringing you a new piece of content all about keeping the Superfluid protocol solvent. So today what we'll do is we'll walk through one, why we need to keep the network solvent in the first place, two, how this solvency mechanism actually works in detail. We'll spend a lot of time looking deep into it. And then three, I want to walk through how you can participate. This is an open system. Anybody can participate and anyone can earn rewards, financial rewards, for taking part in this ecosystem. So I'll show you how to get started with that in practice as well by running what we call a Sentinel node. Alright, so before we get our hands dirty and actually run a Sentinel, what I want to talk through is how this mechanism for solvency works in the first place, why we need it, and what are the particulars under the hood. Now, to really understand why we need this, we need to understand what happens when a superfluid stream is created and how it works under the hood. So when you create a stream, you have to define the super token you want to use, the receiver you want to send funds to, and the flow rate, which is the number of tokens that you want to send per second. Right? One thing you don't have to do there is lock up the entire amount that you want to stream in a separate contract. You just have to keep your token balance above 0 and the stream will stay open. That's an amazing thing because it's great for personal capital efficiency or capital efficiency for businesses or DeFi protocols, but it does require some extra work on the protocol's part to make sure that things are all in good standing, right? So when you create a stream, you don't have to lock up the entire amount you want to stream in a separate contract, but you do have to lock up 4 hours worth of that stream, right? That number may change at some point in the future by a bit, but as of right now, the amount is 4 hours worth of the stream. Now, that 4 hours is what we call a buffer, right? It helps incentivize Sentinels to close streams if your balance hits 0. Because if we think about it, right, if I open up a stream and I want to send the equivalent of $1 per day, and I only have $7 in my account, if I don't add additional tokens to my account at the end of the week, or if I, for whatever reason, just forget to close the stream at the end of the week, what will happen is our balance will hit 0. And we need to think about what happens when the balance hits 0, right? If there's nothing there to close your stream when the balance hits 0, that wouldn't be good, right? We don't want to have any negative token balances. So solvency is the job of the Sentinel network. And to really understand how a Sentinel is incentivized, we need to talk through both the specifics of each solvency state, right? What happens when a token balance hits 0? And then we need to talk through how a Sentinel is actually compensated, right? Because it isn't as straightforward as just the Sentinel will receive the entirety of the buffer amount. It's a bit more nuanced than that. So here in our docs, we have a nice section here on liquidations and toga, it's called. I'll explain what toga means in just a second, don't worry. But the first thing we see here in this liquidations and solvency section are the 3 different solvency states an account can be in. Okay, so the first solvency state is solvent, right? Everything's in good standing, nothing to worry about. A user's token balance is greater than 0, so all is okay. The second state is the critical period. Okay, so now in the critical state, the sender's balance is now 0, and the permissions on the stream let anybody close it, right? Until the stream is closed, the buffer is used as a kind of backstop to allow the flow to stay open so that tokens are still being sent to the recipient. From the Sentinel's point of view, this critical period is divided into 2 sub-periods, right? The first is the patrician period, or the priority period as it's sometimes called, and the second is the pleb period, right? If a stream is closed during the patrician period or the priority period, the entity that's going to receive the buffer reward, the remaining buffer reward, is going to be the patrician, or the patrician in charge, right? The patrician in charge of the PIC is someone who stakes funds to receive rewards that are received, to receive rewards that are earned in this period by closing streams. The patrician in charge will earn the reward regardless of which Sentinel closes the stream, if it happens in that period. So that patrician period is early on. However, right, I have a nice diagram up. It's short right? So it's the first small portion of the priority period, or of the critical period, I'm sorry. And this is where the patrician in charge will receive rewards, okay? So to see who the PIC is on different networks, you can see this inside of our TOGA dashboard, right? toga.superfluid.finance. TOGA is short for Transparent Ongoing Auction. To become the PIC, you can just stake an amount that's greater than what you see here as the current bond amount, right? So if you wanted to become the PIC and receive all the rewards that are received by closing streams inside of this priority period or the patrician period, you just have to put up an amount that is greater than this 412, right? So I can put up 413 FDIX right now, and I can become the patrician in charge and receive those rewards. It's open to transparent ongoing auction. Okay, so what happens if the stream is not closed in that initial period? Then what? Well, this brings us into the pleb period. And in the pleb period here, this orange period, this is the rest of the critical period. The recipient of the reward here is going to be whatever sentinel closes the stream. So here, remember, in this period, regardless of which sentinel closes the stream, the PIC is going to receive a reward inside the priority period, right? However, if they miss, or if just the stream is not closed here yet, the direct recipient of the remaining buffer reward is going to be the whatever sentinel closed the stream, right? So this is an incentive for sentinels who maybe don't have the capital to become the PIC, right? They don't have the capital to stake this amount. They're still rewarded with the remaining buffer, depending on when they close this. So if they close the stream directly halfway between the beginning and end of the critical period, they'll receive half of the buffer as a reward, right? And whatever proportion they receive will depend on how late they close this. Okay, so that's the critical period. The third period, the period we'd like to avoid, is the insolvent period, or the insolvent state, okay? This is a bit of an open-ended time frame, right? But what it means when an account is insolvent is that the entire buffer has been used to keep the stream open, right? So the entire 4-hour buffer is gone, and now we really need a sentinel to close the stream. And we call this segment the pirate period. So during the pirate period, it means that A, the buffer amount is 0, right? But what it also means is that this is when an individual sentinel who's not the patrician is very incentivized to close the stream and to close it fast. Okay? So if a pirate closes a stream here, what they receive is a reward that is equivalent to an amount that is slashed from the PIC, right? So this part of this staked amount that the PIC had to put up is slashed. It's paid out to the pirate, and that's their reward there for that, right? So it is a bit of an incentive mechanism there. If we look a little bit deeper into how this works, I'll explain a bit more in detail the specifics and recap here for the patrician and pleb in a second. But for the pirate, they're going to receive the rewards that are equal to the size of the original deposit, right? So the entire 4-hour deposit might be gone, right? Might be eaten through here during the entire critical period, but the amount that they're going to receive is going to be equivalent to the entire amount of the buffer, but it's going to be taken directly from the PIC's bond, right? So we are making sure, right, via this interesting game theory type mechanism, that the patrician in charge is strongly incentivized to make sure that streams are closed early, because that's when they get rewards. And if they close it early, it also prevents an account from going insolvent, which would mean that they're going to lose money. And we also incentivize individual actors who are running sentinels to earn money in this pleb period and the pirate period independently, right? So again, we're somewhat proud of this system. We think it's interesting in that we provide a bit of a backstop using the staked amount from the PIC, to keep the protocol solvent, while also directly incentivize individual actors. That could be you, it could be future teams that build on top of Superfluid, it could be professional DevOps organizations, right? We're incentivizing all these different actors to close streams and close them quickly, right? Because there is a reward. Now, before we move on and get more into like running the Sentinel, I do want to talk through this PIC mechanism just a bit more, and how you can become the PIC, right? So you can become the PIC by connecting a wallet here, right? Like I can connect my wallet, and there's a button that will pop up that will allow me to become the PIC on this dashboard. But what's happening under the hood is, I mentioned it's a transparent ongoing auction, so anybody can become the PIC at any time if they're willing to stake more than the previous PIC. And it's quite simple, right? So you're a PIC hopeful, you're not the PIC yet. You send tokens to the toga.sol contract, and if it's greater than this amount, you become the PIC. So you can see here in this Toga contract, this is inside of our repo, right? It's in the Ethereum contracts package under contracts utils, right? Toga.sol. You can come in if you're technical and want to really understand how this works. You can come in and read the different comments here. I think it's quite well documented by our team. But if we scroll down, we can see where the logic is actually taking place, and it's happening inside of this ERC777 callback, right? So we use the tokens received callback, and all we do is we check which token was sent, we check what the current staked amount is, and if the new staked amount, or if the new amount of tokens sent to this contract is greater than that current amount, then we will change who the PIC is. Okay? And the final thing to keep in mind is this exit rate concept. The exit rate is the amount of tokens that the PIC is going to stream out per day, right? So yes, you do have to lock these tokens up, but you can make sure that you have some kind of exit rate so that you're removing tokens, on a day by day basis, right? So that's how the Toga works, and that's an overall breakdown of how this mechanism for solvency works. Again, just as a recap, we've got patricians, plebs, and pirates. The patrician puts up an amount of capital, which serves as a kind of extra backstop mechanism, and also an incentive for them to receive additional rewards if they put it up to become the PIC. And then the individual Sentinel can close the stream in either the pleb period or the pirate period, and depending on when they close it, they'll receive rewards that either come directly from the buffer, right, or directly from a slashed amount that comes out of the PIC's stake. Okay? So we're here if you have any questions on this. We can discuss it in further detail if you'd like, but let's get into the process of actually running a Sentinel. So let's think about who we expect to actually run Sentinel software, right? Before we get into how to actually do it, who do we expect to run a Sentinel? Well, as we've laid out, this is an opportunity to earn money, right? So if you want to become the PIC, we've built a dashboard for you to manage your PIC positions. You can, if you'd like, connect a wallet and decide to become the PIC for a given token if you'd like. You could do that either on Polygon Scan, you can just on the contract directly by sending tokens, or you can do it in this dashboard. You can manage your positions here. So for example, if I'm the PIC, I'd be able to see all of this, and I'd be able to see the exit rate and all of this stuff. Obviously, this could have the potential to become a solid business, right, for entities that want to do this professionally. But the other category of entities that we expect to run Sentinel software are people that want to just make sure that their own services are protected. So for example, if you launch a new token, you might want to make extra sure that your users are not going insolvent. Anytime a token is added to the super token list, right? So if you deploy a super token, it's going to be listed, it's going to be watched by other Sentinels, because that's just how the Sentinel software works. But you may want to provide extra guarantees to those using your token. Maybe you become the PIC, and all the rewards you receive as the PIC, maybe you just decide to give those back to the people that got liquidated if they did get liquidated, right? So it's worth keeping that in mind, that if you're going to launch some service built on Superfluid, you should probably know how to run this software, and you should strongly consider protecting your own service because it could provide additional benefits to those using it. So yeah, those are the kind of the two main categories. There's also people that just love to participate in Web3 networks they find interesting. If you're one of those individuals and you just want to help secure the network, what I'm about to walk through will help you get started, right? Running a Sentinel is quite easy. If you're doing it for money, right, there's maybe some more professional DevOps skills involved here to, maybe write a new variation of the Sentinel that's extremely high performance, right? Maybe you want to write a version in Rust or Go that's incredibly fast. You could do that and try to beat everybody to these liquidations. Same thing like with the bond. We expect this amount of capital to increase, especially on tokens like USDCX or DAI or heavily used tokens. So like this could become a fairly professional endeavor. There could be a DAO that is launched around this. These are the kinds of things we're expecting. There's already a guild, a Sentinel guild that's popping up that's being led by community members where people are really thinking hard about how to professionalize this. So again, it's just some high level understanding for you on who we expect to run these. But now let's get into the process of actually running a Sentinel. So what we'll do is we'll run a Sentinel using a remote machine that I have, just like a cloud service. We use Docker, and I will stage a liquidation for you to show you how this looks in real time. Okay. So I have on the right-hand side of my screen the Superfluid Sentinel repo. This is inside of our GitHub account, right? You can find it at Superfluid Finance, Superfluid Sentinel. Nuno from our team he's one of the people that's taken the lead on this. He's done an incredible job of really helping to maintain this. We have a repo here, or a README here, rather, that will walk you through how to get set up. And I have my command line up here to show you how my, directory looks. So here I am inside of the Sentinel repo where I'm going to run our Sentinel. Let me pull up our .env file. Don't worry, I'm using a private key that even if you take my tokens, it's going to be okay. It's all fake. It's all fake anyway. So if you see here, this is the .env file. It is based on the template found here inside of this file, the .env template. And all you need to do when you get to this repo is clone the repo, okay? Pull it into your own directory and create your own .env file, and make sure that you have, at minimum, what you need is the RPC node here, right? You see I'm highlighting this on the left side of my screen. And you also need a private key. Okay, which is going to be an account that has native tokens on whatever network you're going to use that can pay for gas fees for liquidations. Okay, that's also where if you end up closing a stream in the pleb period or the pirate period, you'll receive rewards at that address as well. And if you become the PIC, you can become the PIC with this address too if you want to. So, if we scroll through these different parameters, I'll walk you through each of them and why I put each amount. Okay, so here we have the RPC node. That's fairly straightforward. I'm using an RPC URL from Alchemy that I got for Guerli, which is the network we're going to use here for this demo. We've got a private key. This fast sync bit will allow us to easily, boot up our Sentinel. What's happening behind the scenes, we have a database here that's a part of this Sentinel software. If we use fast sync, this is just going to allow us to load that database faster. You can also, if you want to do it quickly, you also need an IPFS gateway here, so you can include your own IPFS gateway. Here, when syncing, the Sentinel is going to make range queries to the RPC node in order to get log events. If you have a larger value here, this is going to make it so that your node will sync more quickly. So if I increase this right to 5,000, I guess I need to actually make it so I can insert here. Let's increase this to 5,000. It'll just allow my node to sync a bit more quickly once I get booted up. But keep in mind that different RPC nodes might have different limits. So if you put a really high number, you might get rate limited by your RPC provider. So just be careful there. This polling interval is the interval in seconds at which the Sentinel is going to poll the RPC for new updates. I think the default setting inside of the README here is 30 seconds. I've got mine a bit quicker at 15 seconds. I'm not setting a block offset beyond what we have here as the default, but this is just a number of blocks that these sentinels should lag behind when they're updating chain state. It's worth looking into the how the chain you're going to be operating on is set up, right? This is a protection against reorgs, right? So if you're dealing with a chain that you believe is going to have very few reorgs, or it's not going to be an issue, you can make this smaller if you want. And then in terms of protocol parameters, we've got the protocol release version. In our case, we're going to use v1 for the Superfluid contracts. We also have a PIC account we can set. If you set this, the Sentinel is going to watch if the configured address becomes the PIC, and if it does, it will make sure that your account, the one associated with the private key here, does liquidations during that priority period, right? So during this period, if we scroll up here, right? So if you are the PIC or you want to be the PIC, you need to put the address of the PIC here so that the Sentinel knows to liquidate positions early on in that critical period so that you can actually get the rewards as the PIC. Okay, so here in this token selection section, by default, your Sentinel will watch the entire network you're on for super tokens that need to be liquidated. If you'd like to just liquidate a single token, you can do that, or a handful of tokens, you can do that. Right now, it's not really going to matter very much because there aren't yet thousands of tokens to watch, right? If there are thousands of tokens to watch, you might have a desire to focus on like the list that means the most to you, because there might be more complexity at that stage. But for right now, it doesn't really matter too much. And then on the liquidation parameters themselves, you can set these. So if you want to not do any liquidations and just observe, you can set this to false. The reason why you'd want to potentially just be an observer is that you can get really interesting log data on what's happening in the protocol by running a Sentinel, just like you can get interesting data if you're running like a Ethereum client, right? Literally entire RPC providers have sprouted up because they run hardware like that. So, if you'd like to be an observer, you can. We have an additional liquidation delay. This can be set as negative, right? And I'll explain why in a second, but what this does is it allows you to add a delay in seconds between an agreement becoming critical and the Sentinel sending a liquidation transaction. So you might, for some reason, say you're running a backup Sentinel, right, that you want to be like a failsafe. You can preset a number of seconds to pass after your Sentinel finds that an account is critical to wait until before liquidating the account. By making this negative, you can actually make it so that there's a negative delay. There's a default delay here as is, right? Which is, I believe, a few seconds, right? And if you decide to have it as negative, you can make it so that, you're even more on top of things, I suppose. Okay, so we also have a couple of other settings here. One of them is the retry gas multiplier. There are situations in which, if you've ever interacted with blockchains, you know this, where you might send a transaction and either the transaction gets stuck or it fails. In the situation that happens, if we're doing liquidations, we want to retry. So what we'll do, and you can see this down here in this transaction timeout setting, we'll wait a number of seconds, in this case 60 seconds, to retry the transaction if it doesn't process. And when we do that, we will have a retry gas multiplier of 1.5. So we'll try again with 1.5x the amount of gas, right? And if it fails again a second time, this will just continue to get ratcheted up. And the math here helps you understand how this is going to work. Okay, reaching the end here of different parameters. We have a max gas price setting. So the default is 500 Gwei. Mine's a bit more than 500 Gwei. So you can see here, 500 Gwei is what was listed. I've got a bit more just because I'm willing to spend more. You don't want this to be set too low because it could mean that your transactions remain pending too long and you have to just burn even more gas by trying it again and again, and you might miss liquidations that you should be getting. But if you have it set too high, you could be wasting gas, right? So this is kind of at your discretion. Again, we recommend something in this 500 GUI range, but it's going to matter depending on your network and network congestion and all of that good stuff. Finally, some technical parameters. If you have a custom path to a SQLite database, right, which is the database that's going to be used within the Sentinel to help run your Sentinel, you can enter that here. This is the default path, and if you're using Docker, it's overridden. But for me, I'm just going to comment this out. I'm not going to set this parameter. So log level is another one. This is actually pretty important. It'll determine how much data you're going to get as your Sentinel runs. The one that will provide the most data is the debug setting. That's where I have it set, partially just to show you how this looks. But you can also have it on any of the other 3 settings, which will show you less information. This metric section is set as true by default. It will give you some metrics on port 3000 wherever you're running your Sentinel, and you can customize the port if you want, or you can just turn it off entirely if you'd like as well. Okay, a couple of other parameters I have set here is just the number of the max batch transaction number. So the one thing that's happening as you're liquidating accounts as the Sentinel is if you have multiple liquidations to do at once, your Sentinel will send a batch transaction to batch liquidate, which means that you can include multiple liquidations in the same transaction. So you only have to pay gas once to liquidate multiple streams. It's an efficiency you can find elsewhere in our docs and about the protocol and how to create your own batch transactions if you want. But we might want to set a max, right, just for gas price purposes. And then block offset and cold boot. I'm not going to worry about these for now. These aren't even really set in this section, but these are kind of some more advanced class stuff. Okay, so we've got our .env set up. Let me Control-C out of this and save. And where I am running my Sentinel is inside of a Docker container. You can pretty easily run it yourself on your local machine. I'm just running it in a Docker container in the cloud here. But all right, if we take a look at the README, head to Docker. All right, here's just some notes on getting this set up. Again, it's just explaining what I just explained to you about configuration and all this good stuff. Cloning the repo, installing dependencies, all this good stuff. If you want to use this system control, you can. Docker. Okay, here we are in Docker. Okay, so I've already built the Docker image, so I don't need to worry about that. But to run the Docker container, what I'm going to do is run it in the background. So we'll run docker compose upd. I have docker compose installed, so I don't need to worry about installing it, but we can run our container. Okay, there we go. We're recreating Superfluid Sentinel. Made a mistake there. I needed to include docker compose up. Okay, so the Sentinel is running. And what we'll do is we'll run this docker compose logs and add f to follow a live log. Okay, so docker compose logs f. All right, we can see that the Sentinel was booting. We're getting a snapshot from the default IPFS path here. Connecting to our node, we can see other information here about what account this is. So I can see the account it's gotten using the provided private key. The protocol can, not the protocol, but the Sentinel can figure out, okay, this is the Gurley network. Here are the addresses that are important on the Gurley network. What's the balance of your account? All that good stuff. All right, we're just loading here. We're syncing. This takes a second to sync. And while this waits here, what I'm going to do is head over to an account that I know exists and make sure that we have a stream that's about to get liquidated set up here. So I'm going to stage a liquidation for us, which would be a lot of fun. Okay, so we have a balance here in this Superfluid dashboard for DAX in this account. So I have a script that I'm going to run here on the side, which will open a stream that I know will indeed get liquidated. Okay, I'm going to wrap some tokens, so I'm going to wrap a very small amount where I know this is going to get liquidated very quickly. Okay, I'm going to upgrade some tokens there, and then as soon as this is upgraded, I'm going to create a, as soon as this is upgraded and as soon as my Sentinel is ready to go, I'm going to create a stream where I am basically going to guarantee that this account is going to get liquidated right away. Okay, so we've got very, very little money. I'm going to open up a stream that just burns, takes a $1 deposit and burns through this amount right here very quickly. Okay, so now that we've done this, I'm still waiting for our Sentinel to boot up. It's just syncing. It takes a second to sync sometimes. Let me go to our Toga dashboard, and we're going to go to DAX on Guerli. So DAX, I got to make sure that I have the right DAX. There's quite a few here that have been deployed on test. Okay, we can see here we have info on liquidations. And if I go back to the Superfluid network directory, we can query on Etherscan who the current PIC is. Okay, so I have the token address. Once again, we'll do fDAX, this number here. And the current PIC is going to be the PIC that I included here. So while this loads, let's go back to my .m file. The address that I have that I'm using as the PIC is this one here. So it ends in 7721. I'm looking for this. I've copied this address, so we're going to query for the DAX PIC. If I do get current PIC, we can see that this is indeed the PIC. So I am the PIC, which is awesome. If you want to see more information about like the bond and the exit rate for the PIC, I have a 0 exit rate, so I'm not having any amount flow out, and I have a bond that is worth this much, so about 366 tokens. Okay, so we're back. I had to pause it for a second. It just took an extra second for our Sentinel to sync. But you can see here, where we left off is at this section where it was getting the snapshot. Finally, once we got the data, we unzipped the snapshot, and we got all this information here. So let me expand. Okay, we have a lot of the parameters we entered in here inside of our .m file. We can see that the Sentinel is syncing. As it syncs, it gets all the tokens we're going to watch. Alright, so it lists them all. And then what it starts doing is giving us these logs, right? So it gives us estimation queues for different transactions. We can see here this is a liquidation job, right? So here, sometimes we'll run a liquidation job. It'll say running liquidation job, and there's just an empty array. I'll find an example here in just a second, but we can see running liquidation job. This right here is a liquidation job, right? So for this super token and this super token, we actually had several super tokens here. A liquidation job was run. And we actually have the number of transactions in terms of liquidation jobs that have been done, which is kind of interesting as well. Okay, we've got info on metrics that we're listening to. And again, just because this is on the debug setting in terms of logging, we're getting lots of information. But what I want to do right now is open up a stream and stage a liquidation so we can see what's actually happening here inside of our command line. Let me bring this up just a bit so we just are seeing the most recent information. You can see here every few blocks we'll get a return of just an empty array for after running a liquidation job. This means there wasn't a liquidation job at all. We're just constantly getting information about the protocol. We're logging it. Right. This is another reason why you might want to run a Sentinel without running any liquidations, because you can get some interesting information on what's happening at the protocol level. So let me run my script over here that's going to open up a stream. Okay, it's running. And I'll open up our dashboard with our account. I'll refresh, right? So pretty soon, because the Sentinel is running a few blocks behind, soon we will see information about a liquidated account inside of our logs, inside the Sentinel. Okay. So I just expanded our screen here. We just got a bunch of information about a transaction hash. So what is this transaction hash? Let's copy this, and we will go back to Gurley Etherscan. I will paste in this transaction hash. All right, we can see that this was a call agreement, which means that something happened with the Superfluid agreement. It was from this address. Now, who is that address? This address is the address of my Sentinel. Okay, this is the address associated with the private key. So we can see information that proves that, okay, we just ran a liquidation job. Check that out. Right, we have information about it, and we can see back in our dashboard, all right, the stream is stopped. Okay, so I can refresh. Sometimes this stream will appear to be negative on the dashboard when in reality it's often not. Right, the balance is just 0, and look at that. If we also go to the TOGA, we can also see that it's likely, if we get the current PIC info, it's likely that our bond amount would have increased if this was closed out in the priority period. It's going to be tough to compare. I can prove it to you though. If we go back in our video, if you go back in the video, I swear, the old bond was 366, right? So it's ticked up by just a little bit, right? I think it was ticked up by just a little bit to push it up to 367. The PIC has earned money by providing valuable services to the network, and the Sentinel that we're running has helped us as the PIC in closing out this stream. So you just saw end to end us spin up a Sentinel. This Sentinel is now watching over the network. It's keeping the network solvent. It's running in the cloud for us. So right now in Gurley, you're watching live the Superfluid protocol stay solvent, right? Which is pretty cool in my opinion, right? We're participating in a really innovative new Web3 primitive, and this is something you can do as well. It didn't take us very long to set this up. All I had to do was spin up a server here and configure my .m file, and I was good to go, right? It took very little time. You can do this yourself pretty easily by just, if you want to run it on your local machine as an experiment, we have instructions on how to do that here inside the Superfluid Sentinel repo. Again, like, all you have to do is clone the repo, install dependencies, create your own service template, and create your own .m file, and run the Sentinel, right? Either using npm start or using the system control, right? Pretty easy to get set up, really easy for you to participate, right? So to finish off our session today, the last thing I want to do is just show you how you can run queries to learn more about liquidations. So if we go to, let's go to the Superfluid Console and zoom in. Let's go to the Subgraph Explorer. You can see here I have a few different query types that I can make about agreement liquidated events. So let me click on this here. And let's get just the ID to start to show you that these are being listed. Let's query where the liquidator account is the address that is closing streams for us. So let me go over back to Etherscan. I'll copy this address. I'll make sure we're on Gurley. And then we have to do this annoying thing here to make sure that the address is all lowercase. I actually think it is for us, which is kind of nice. All right, so we've got some agreement liquidated events. That's pretty cool, right? We can see the IDs of them here. Let's also get more information on them. So let's see what else I can get. Let's get the addresses. Let's get the liquidator accounts, which is, I guess, just going to be the address we put in. Let's get the token and the timestamp. Nice. Okay, so these are the addresses involved. This is the liquidator account. Oh, and that's interesting. It's actually the amount of times that the the account that's been liquidated is okay, so let's go to the Guerli network and let's get the agreement liquidated by events. So let's go to agreement liquidated v2 events. Let's get them and let's see the let's not do where yet. Let's just order by time. Order by timestamp, and we'll do descending. I believe that's what we need. We need most recent. Okay, so we have the most recent liquidation events, and let's get the liquidator account and liquidation type. Let's see what we see. Liquidation type, okay, we can see the most recent event that was liquidated was by our address, right? If we can verify, this is the address. This is the most recent one, okay. Let's also get the token. This will give us the token address. Okay, this is the address of DIX. Let's get all of the agreement liquidated events where the address is the one that I've been using, okay, as the Sentinel. So let's do a where clause where liquidator account is this address. Okay, and we will save. We can see that I've done just a handful of liquidations here, and we can see the tokens that there were liquidations on, which is pretty cool. Nice. So that's how you can query. You can see, through the graph, the liquidations that you're making, right? So you can imagine you turning this into a kind of like dashboard for yourself, or you can imagine what's happening behind the scenes in this dashboard, right? So we're using the graph to get information on the most recently liquidated streams on whatever network we're using. Okay? So again, this is a walkthrough on how to participate in this portion of the Superfluid protocol. I would highly encourage you to do some research, right? Read our docs on the liquidations process. Familiarize yourself with this. We have a whole section here about the buffer or deposit, which gives you more details on how profitable it would be to be the pleb versus the pirate versus the patrician. It breaks this down. It shows you where you can see up-to-date information on like what parameters are set here for like when does the pleb period start, right? These are all governance parameters set by the Superfluid protocol at large. You can see all this here. I will put links to this inside the description of this video. And again, like I would really encourage you to consider taking part in this network, right? Again, not everybody's the right fit to run a Sentinel and run this kind of infrastructure, but we do believe that this can be a kind of profitable business endeavor for people that want to be professional Sentinels, right? That have DevOps skills, that want to do this in a professional way. And we also believe that this is great for people that just want to get involved, or teams that need to secure their own services, right? So if you want to make 100% sure that the individual token that you're either launching or the service you're providing, that those users remain solvent, you can run a Sentinel to ensure that. And you can also become the PIC for your own token and effectively provide guarantees back to your users that maybe you want to make sure that you give them back tokens in the event that they get liquidated at an amount that's larger than a certain amount that you set, right? I don't know, right? There are all kinds of arbitrary things that you can set here. And I'd encourage you to get involved in the community as well. So there's the Sentinel Guild, which I'll put a link to, their Discord server in the description. They're building lots of different implementations for the Sentinel, right? I mentioned earlier high-performance Sentinels in Go or Rust. They're working on those things. If you have those kinds of skills, if you know low-level programming languages, if you understand DevOps very well, they would love your expertise. And yeah, so I would love your feedback on this video, whether or not it's helpful. We'd love to see more of you run these kinds of infrastructure to help secure the protocol. And we're here if you have any questions. So thank you for watching. Thank you for your interest in participating. And we hope to hear from you soon. Thank you.